Today we're going to see how standard mechanical calipers are used. The caliper is one of the most common all-round measuring tools. Because calipers often have several measuring surfaces, they can measure inside, outside, and depth dimensions with an accuracy down to 1/1000th of an inch. Although calipers come in different sizes, there are two basic types which are most commonly used. One is the vernier caliper, which has a main scale and a vernier scale. The caliper in more common use is the dial type. Measurement readings are taken from a main scale on the beam and from a dial face. Standard calipers consist of a beam or bar with graduated scales on which these jaws move. The inside measurement jaws are here, with their flat measuring surfaces facing out. They are used for making inside measurements. The outside measurement jaws with the flat measuring surfaces facing in are here. Note that each set of jaws has one fixed jaw and one adjustable or movable jaw. The movable jaws are connected to the slider. Either a thumb clamp or a wheel is commonly used to move the slider and adjust the jaws to the proper measurement position. To measure an OD, or a thickness, you would open the outside jaws of the caliper to a distance slightly wider than the dimension to be measured. To measure an ID, you open the inside jaws slightly less than the diameter. In either case, the caliper's jaws are then moved against the dimension, arcing from left to right. This aligns or squares the jaws with the surface. Finally, the caliper's jaws are adjusted tightly enough so that they create a slight drag against the surface to be measured. When the jaws move, the depth blade also moves. When the edge of the beam is held this way, at an edge or a hole, steps or depth can be measured by using the depth blade. Like other measuring tools, calipers are available in decimal inch and metric scales. Let's first examine the vernier caliper to see how its scales are used to take measurements. All calipers have at least one main scale on the beam, often called the beam scale or the bar scale. This caliper has two main scales because it is designed for taking measurements in decimal inches and in millimeters. And there are two vernier scales on the slider, one for decimal readings and the other for metric readings. We will concentrate on the decimal vernier. The decimal vernier allows precision readings to 1/1000th of an inch. It operates in similar fashion to the vernier on the outside vernier micrometer we looked at in Lesson 2. However, this vernier is laid out flat, parallel to the caliper beam. Each division of this decimal inch main scale represents 25/1000ths of an inch. Each fourth line marked by a number indicates 100,000ths. Here, the longer lines and larger numbers indicate inches. The line indicated as 1 represents 100,000ths. The line indicated as 2 represents 200,000ths, until we get to 1 inch, 2 inches, 3 inches, and so on. This point on the main scale is 300,000ths. And here the reference line is two short graduations beyond 500,000ths, which indicates 550,000ths. Remember, each smaller line equals 25,000ths, so two lines beyond the number means an additional 50,000ths. This point on the scale indicates 2 inches and 175,000ths. The key to reading measurements taken with the vernier caliper lies in understanding that the basic reference line is the 0 mark of the vernier scale. You obtain the reading by noting where on the main scale the 0 mark of the vernier scale indicates. Here, The 0 mark on the vernier scale indicates a reading of 900 thousandths of an inch. Remember, the reading is taken where the 0 mark on the vernier lines up with a graduation on the beam's main scale. The steps in taking a measurement are similar to those used with the outside vernier micrometer. First, determine the number of inches the vernier 0 mark has passed. In this case, it has passed the 2-inch mark. Next, note the 100 thousandths graduations that the vernier 0 has passed. Here we can see it has passed the 100 thousandths mark. Then determine the number of small divisions past the 100 thousandths mark the vernier 0 indicates. Here, the vernier 0 is lined up exactly with the first line past the 100 thousandths mark, indicating 25 thousandths. Because the vernier 0 lines up exactly on a scale line, we can take a reading by adding only the 3 main scale graduations. In this case, it is 2 inches plus 100 thousandths plus 25 thousandths, which total 2 inches and 125 thousandths. Here is a measurement on the vernier caliper. Can you tell what reading is indicated? Be sure to notice that the 0 mark of the vernier scale has passed the 3-inch mark. It has also passed the 200 thousandths graduation. Finally, the 0 reference line corresponds to the 3rd graduation past the 200 thousandths division, indicating 75 thousandths. And so 3 inches plus 200 thousandths plus 75 thousandths equals 3 inches and 275 thousandths. For measurements accurate to a thousandth of an inch, the vernier scale is used. Again, the vernier on the caliper is similar to the one found on micrometers. But remember, the vernier on the micrometer is capable of indicating measurements to tenths of a thousandth, while the vernier caliper indicates measurements to only 1/1000th of an inch. The vernier on the caliper is an enlargement of the 25 thousandths markings between minor divisions on the main scale. When the 0 reference on the vernier scale does not line up exactly with a mark on the main scale, then a reading of the vernier is required. To read the vernier scale on the caliper, locate the first graduation of the vernier after the 0, which coincides precisely with one of the divisions on the main scale. Then you read the number from the graduations on the vernier. For example, here the first graduation on the vernier, which lines up exactly with the division on the main scale, is 5. This is a reading of 5 thousandths. Naturally, it takes a little practice to see where the graduations line up precisely because the lines are small. Now let's review how to take a measurement down to 1/1000th of an inch. First, you determine the number of inches the vernier 0 has passed. In this case, it has passed 1 inch. Next, determine which 100 thousandths the reference 0 has passed. Here it has passed the 100 thousandths mark. It has also passed the first 25 thousandths graduation. But because the vernier reference 0 has not exactly lined up on a 25 thousandths line, we must read the vernier scale. The first graduation on the vernier scale, which coincides with a line on the main scale, is here, 13 thousandths. Finally, we add up the results. 1 inch plus 100 thousandths plus 25 thousandths plus 13 thousandths. This gives a total measurement of 1 inch and 138 thousandths. The dial caliper operates in a similar manner to the vernier caliper, but its design allows for easier and quicker readings. Measurements are obtained by taking the combined readings of the main scale and the dial. To hold the measurements, this caliper has a lock nut on the top of the slider. The markings on the main scale are much simpler than on the vernier caliper's main scale. Each large number indicates inches, while the smaller numbers on the minor divisions indicate hundred thousandths. For example, this point on the main scale represents 5 inches and 300 thousandths. The dial is calibrated so that each complete revolution of the pointer represents 100 thousandths of an inch. Every 10 thousandths is numbered: 10 thousandths, 20 thousandths, 30 thousandths, and so on. Each division between 10 thousandths marks represents 1 thousandth, with the slightly longer line indicating 5 thousandths. If the pointer indicates a reading between graduations, it is usually rounded off to the nearest thousandth. Here, the pointer indicates 3 divisions past the 20 thousandths mark, or 23 thousandths. Here, the pointer indicates a reading at the 2nd division after the 90 thousandths mark, which reads as 92 thousandths. In order to take a total reading with the dial caliper, the indication on the main scale is read, then the reading on the dial display is read and added to it. First, the caliper jaws are positioned against the object being measured, and either the thumb clamp is released or a lock nut is tightened to hold the measurement. Next, we determine the point on the main scale that the edge of the slider indicates. Note that the dial caliper is different from the vernier caliper, which utilizes the 0 point on the vernier scale as its reference. On the dial caliper, the beveled edge of the slider is the reference line. We note the number of inches the edge of the slider has passed. In this case, it has passed the 2-inch mark. Then we note how many hundred thousandths beyond the 2-inch mark the edge of the slider has passed. Here, the edge is slightly past the 300 thousandths mark. Next, we determine the number of thousandths on the dial indicator. The dial indicator is pointing at 6 divisions past the 30 thousandths mark, or 36 thousandths. Finally, we add up all the values we have obtained. 2 inches plus 300 thousandths from the main scale plus 36 thousandths from the dial indicator equals 2 inches and 336 thousandths. Here is another measurement on the dial caliper. What is the total reading indicated? As you can see, the edge of the slider is past the 1-inch mark and the 300 thousandths division. The pointer on the dial indicates 1 division past the 70 thousandths mark. 1 inch plus 300 thousandths plus 71 thousandths equals 1 inch and 371 thousandths. Before using a caliper, make sure that the measuring surfaces of the jaws are free of dust and dirt. Use a soft cloth to clean them if necessary. Next, check to see that the device is calibrated before you use it. With a dial caliper, like the one in the Precision Measurements Kit, close the jaws fully. Then, check the indicator on the dial. It should be exactly at the 0 mark. If it is, then the caliper is calibrated and will take measurements accurately. If the indicator is not on the 0 mark, then the device is not calibrated. Call on your instructor for assistance. Read the material and do the practice exercises in your study guide. Then take a little time to make sure you understand everything we've covered in the first 3 lessons. In Lesson 4, we're going to apply what we've learned with some intensive hands-on practice using the devices from the Precision Measurements Kit.